Hello everyone and welcome to another video with Mr. Math. Today we're talking about quadratic equations and we have this problem that says solve x² plus 9x plus 4 equals to 0, but we're asked to solve by the quadratic formula. So a good strategy here is to rewrite the equation x² plus 9x plus 4 equals to 0, and we want to write the standard form of the quadratic equation maybe on top. That will be 𝑎𝑥² plus 𝑏𝑥 plus c equals to 0. Okay, so this a, b, and c are going to be the coefficients. So if we see there's a coefficient here that matches with that a, there's a coefficient b that matches 9 that matches with that b, and there's a coefficient 4 that matches with that c. So it'll be okay if we say that a is 1, b is 9, and c is 4. With this information, now is a matter just to plug into our general formula. Okay, let's remember our general formula says x is equals to negative b plus minus the square root of b squared minus 4ac divided by 2a. Okay, negative b is negative 9 plus minus, we'll have 9 to the square, minus 4 times a, that is 1, times c, that is 4, divided by 2a, 2 times 1. Okay, we'll have x equals to negative 9 plus minus square root of 9 squared. 9 squared will be 81 minus 16 divided by 2. Okay, so 81 minus 16, that is 65. And this divided by 2. Okay, let's take a second just to accommodate information. Okay, so our next step will be to just utilize the positive negative values, so we find the two solutions. Our x1 will be negative 9 plus root of 65 divided by 2. And our x2 will be negative 9 minus root of 65 divided by 2. This should be our two answers. Okay, let's check another video. Okay, on this problem, we're asked to solve the equation x² equals to negative 6x plus 12 using the quadratic formula. Okay, let's start. So we have x² equals to negative 6x plus 12. We want to make this one equals to 0. So I'm going to add 6x and subtract 12 on both sides. I'm adding 6x and subtracting 12. Okay, my equation will be x² plus 6x minus 12 equals to 0. Okay, as we mentioned before, we want to write the standard form of the quadratic equation on top. 𝑎𝑥² plus 𝑏𝑥 plus c equals to 0. So if we match the coefficients, we have this coefficient matching with a, this coefficient b matching with 6, and this coefficient c matching with negative 12. So let's write that down. So a is 1, b is 6, and c is negative 12. This information will be very important for our process. So our equation, the general formula of our equation is equals to, we have x equals to negative b plus minus the square root of b squared minus 4ac divided by 2a. Okay, let's continue. And now we just need to plug the values of a, b, and c into this equation. So we have x equals to negative b will be negative 6 plus minus the square root of 6 to the square minus 4 times 1 times negative 12. divided by 2 times 1. So we'll have x equals to negative 6 plus minus the square root of 36. Negative 4 times 1 is negative 4, and negative 4 times negative 12, that is positive 48, divided by 2. Now 36 plus 48, that should be 84, divided by 2. Now let's remember what we can do with this root of 84. That root of 84, and I'm just going to create a quick note here. The root of 84, only the root of 84, I'm going to talk about that. It could be equals to the root of 4 times the root of 21, because 4 times 21 is 84. So, but the root of 4, we know that is 2. Therefore, we can rewrite this as x equals to negative 6 plus minus 2 root of 21 divided by 2. We're going to pull a common factor of 2 that multiplies negative 3 plus minus root of 21 divided by 2. And this 2 on the numerator and the denominator will cancel out. From there, we can build our solution and say that x1 is equals to negative 3 plus root of 21, and our x2 is negative 3 minus root of 21. Okay, thank you for watching. I hope this video was helpful for you.